Hey, welcome back. Page 35 is our notes today. Isometries and transformations. Our objective on page 35, 1027. Our objective for today, is to identify types of transformations and determine properties preserved by isometries. Okay. So, we have a whole bunch of different types of transformations, and we will go through them together. The first property is a rotation. Rotation. Okay. And rotation is a turn. So if I were to take my little shape here and rotate it, I might rotate it 90 degrees. It would look like this. Okay. So rotation, if I were to use function notation for rotation, it would be a capital R followed by the point it's being rotated around and the number of degrees. I don't know, I'm writing this in red. I should be writing this in black. Rotation, the point of rotation, and the degrees it's being rotated. And we always rotate counterclockwise. So this way is counterclockwise. Okay. So here's my example. If I were to have point O, and I wanted to rotate my heart 90 degrees around point O, it would look like this. So I would describe this as the rotation around O of 90 degrees of my heart. So this would be my heart. This would be the image heart prime. Okay? So I could do this for a point. Okay? I could do this for a square. I could do this for a triangle. Okay? A rotation preserves or keeps orientation. That means if I had 3 points on my heart, it'd be L, U, and V. L, U, and V would be in the same orientation, LUV, LUV, as before, if I went counterclockwise. Okay, preserves orientation, distance, the shape is the same. Preserves angle measure. Okay, so orientation, distance, and angle measure. So this angle that I started with is the same angle that I ended with. Okay, the next type of transformation is a reflection. And I would write a reflection with a lowercase r over the line of reflection. So let's say I was going to reflect my heart again over line L. So I'm going to take my heart and reflect it over line L. It's going to flip over. Grab it here. And take my heart, reflect it over line L. And it's going to end up oriented in the opposite way, so almost like you're looking in the mirror. Okay? So, to write this, so here's my heart. L, U, V. When I reflect it over, the orientation changes. If I go clockwise around, LUV becomes LVU. The orientation changes. The notation for this might be a reflection in the line L of my heart of LUV results in L prime, U prime, V prime. These are not primes. Okay. So what does a reflection preserve? A reflection preserves orientation. Or it does not preserve orientation, sorry. Preserves distance and angle measure. So it's the same size, same angle measure, but the orientation has changed. Just like when you're looking in the mirror and when you raise your right hand, it's your mirrored image's left hand. The orientation has changed. Okay? Next up we have a translation. Now, translation is a slide or a shift, and we notate it in t, x, comma, y. And the x, comma, y tells me how I move in a certain direction. So if I were to put this on a coordinate grid, and I were to take my little heart, come on, little heart. Okay, L, U, V. And I were to translate that heart, so I'm going to take and translate the heart negative, or 3, negative 2 of LUV. That will result in L prime, U prime, V prime. So it's 3, negative 2. So I'm going to move my L 3 spaces to the right. 1, 2, 3. 3 in the positive direction of x, 2 in the negative direction of x. There's L prime. U is going to go 3 in the positive direction of x, 1, 2, 3, and 2 in the negative direction of y, 1, 2. And then V is going to go 3 in the positive direction of x, 1, 2, 3, and 2 in the negative direction of y, 1, 2. V prime. And then I make my heart. This is probably not perfect, but you get the idea. So, a translation preserves distance, orientation, angle measure, so all of these preserve distance and angle measure. So whatever shape we start with is a shape that we ended with in all of these. Whenever distance and angle measure are preserved, it's a special type of transformation called an isometry. An isometry literally means same measure. Iso means same, metry means measure. Okay? So an isometry is a translation that preserves distance and angle measure. So rotations, reflections, and translations are all isometries. So you're thinking, what is not an isometry then? Well, a type of transformation that is not an isometry is a dilation. A dilation is a shrinking or a growing, or expanding really, and we use a D to denote it. A point of dilation, and then the R value, which is our scale value. So point of dilation, and then our scale factor. Okay, so if I were to do this and take my heart, it's a beautiful heart. If I were to do a dilation in reference to the point L with a scale factor of 1/2, this means that all the points would get halfway closer to L. So L would stay the same, so this would be L prime as well. U would get halfway closer, so it'd go halfway in and halfway down, so it's 1, 2, 3, 4, 5, so I'm going to go 1, 2 and a half, U prime. Halfway closer for V, V prime. And there's my dilation. It's gotten smaller. Okay, dilations can also grow bigger. So let's say I were to do a dilation along the point U of 2. So this means that everything is going to get, I should write out the finish of this, of love is L prime, U prime, V prime. Now, because this is a second transformation.
Justin Davis, please come to the main office. Justin Davis, please come to the main office.
I'm going to give each point what's called a double prime. So this is a different transformation. I'm going to double prime it. L prime prime, U prime prime, V prime prime. Okay? So I'm going to take everything twice as far away from U. So U stays in the same place. V is going to go twice as far. So 1, 2, 3, 4. 1, 2, 3, 4. And L is going to go twice as far. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then over 2, 1, 2, and twice as far, 1, 2. There's, and then I make my heart again. This is awful, but you get the idea. Okay. So there is that heart that has been dilated 2 times away from U. Okay, a dilation is not an isometry. And I think that is all we need to know for tonight. Okay, so an isometry is a transformation that keeps distance and angle measure the same. Okay, the image and the pre-image are congruent. The only thing that's not an isometry is a dilation. We're also going to talk about stretches tomorrow, but a stretch is pretty much a dilation in just one direction, so either stretching this way or stretching this way. The Regents doesn't talk about it. We don't really need to talk about it. All right, that's it. Talk to you later.